Hello, everyone. My name is Claudson. As mentioned, I'm a senior software engineer at Form3, and today we're going to talk about refactoring your services with cloud agnostic technologies. First of all, I have to introduce you to Form3. We are a payment platform, which means that when you do a money transfer to a friend, you might be using Form3 without knowing about it. When you do that, you obviously have to select your amount of money that you want to send, but also you have to select a protocol or what we call the scheme. You might be doing it using SEPA, using SWIFT, or if you live in the UK, using FPS or faster payments. Our platform at Form3 handles many of those schemes. If we zoom in a bit, we can understand together how our architecture works in a high level. So when you do the money transfer, we have a payment API, we receive that as a request, and then we do a fan out using SNS and SQS services on AWS. And then we have different services implemented by Form3 to handle that request. We have one service per scheme, and the services might will try to understand if they will consume the message or just ignore it. With this architecture, we can see that it's quite easy. The architecture is quite flexible because we can add new schemes as we want. Form 3 is expanding and going to new markets and countries. So it's quite easy to implement a new service that will represent or be connected with a new scheme. The architecture is also scalable because depending on the amount of traffic that we have in our SQS queues, we can increase the number of consumers to handle that. But for sure, we have some cons, some drawbacks as well. I think the most important one to mention is that in any case of incident of outage in AWS, our SLA, our performance will be directly impacted, which basically means that AWS dictates our architecture and our performance, unfortunately. Because of that, we have decided to evolve our architecture to a cloud agnostic one. What does that mean? It basically means that we will be able to run any of our services in any cloud provider. We will be able to run the same service at the same time in AWS and Google Cloud Platform, for example. But as you can imagine, there are some challenges around it. We have to change our services, we have to change our architecture and our infrastructure because I just mentioned one example on how we are coupled to AWS. We use a lot those services, SQS and SNS, and we cannot do it anymore in the future to be cloud agnostic. So we have chosen some technologies to achieve that state in the future. I think the most important one for us, in my opinion, is NUTS. NUTS is actually a set of technologies to connect services through queues and streams. There are different ways to run nets. There are the traditional nets, an old way called net streaming, and a new way called nets jetstream. But what's important here is that we have chosen nets because it is extremely lightweight, and we have different ways to create a cluster of nets instances. And for sure, we have more control in our architecture than what we have with SQS and SNS. Another key technology for us is CockroachDB. CockroachDB is an elastic, resilient, and distributed database. Cockroach was designed focused on this distributed part of things. So it basically means that we can configure Cockroach to have a cluster and have different nodes spread in different countries, for example. In our case, in Form 3, for example, again, we can define a node in the USA, another one in the UK, and a third one in Portugal, where I'm based right now. We have a really powerful feature in Cockroach where we can flag those nodes based on their locales. And after that, we can also kind of flag the data based on the locale as well. With that, we can, for example, make sure that all of the payments, in our case at Form3, all of the payments made in the UK will live in the UK node. This is just one strategy, it's just one topology pattern. There are many others in Cockroach. This one is good in on one hand because uh, all the data is living in kind of local environment, not local environment, but the read and write in the node is going to be so fast because the system and the database live in the same country, for example. But we also have another topologies where we can replicate the data in different nodes. So I think this is one of the special things of Cockroach. We can run it in different ways. A second important thing is that Cockroach is quite compatible with PostgreSQL. It basically means that if you have integrated already with Postgres, it's quite easy in terms of code to migrate to Cockroach because the SQL syntax is exactly the same. And you might be able also to reuse the driver that you have used in Java and Go from PostgreSQL to Cockroach. Basically, Cockroach has most of the features of PostgreSQL, and that's quite good because we don't need to learn a new language as developers. I think it's important to mention as well that we have a podcast, a tech podcast at Form3. And in the 13th episode, we made an awesome interview with a Cockroach team member. There are a lot of good content there, and I really recommend you to listen to it. It's really good. Um, for sure, we have more and more technologies at Form3 that are enabling us to achieve that cloud agnostic architecture. I think these ones actually are here more to connect the dots, like connect the databases, the streams, and the services, and make the architecture done, basically. But until now, I have spoke mostly about the infrastructure side of things, and I would like to be closer to the services and show how them work with you. I think the first thing that we did in the beginning of the project we created a local configuration, which is kind of a feature flag. There are some differences that I'm going to present in the next slide. But basically, we have this image in the right side of the slide where we have a service A that looks at the feature flag and decide based on the value if it will post or publish a message on SQS, as in the old architecture, or on NATS in the new cloud agnostic architecture. Another important thing that we did was duplicating a job in our CI server. We use Travis for many of our repositories, so we duplicated the Travis jobs, and this job basically contains a lot of high level and automated tests against our platform. So with those jobs, we enable the feature flag just in one of them. And with that, we make sure we have confidence that all of our services are running and behaving in the same way. Here we have a more complex scenario where we have different services, but actually there are just two type of services, the service A and the service B. And they are running in different cloud providers in AWS, Google Cloud Platform, and Azure. If we look at service A in AWS, we can see that it is running in cloud agnostic mode, which is represented by the green flag. This service is exactly the service that I mentioned in the previous slide. So it is trying to understand if it will post a message in SQS or on nets. But I didn't mention a small detail about our configuration. Our feature flag is actually done in the level of the customer, which means that when the service A receives the payment, it looks at the payment, look at the customer of that payment, and checks if the feature flag is enabled for that customer. That's quite important for us because it means that for some customers, Service A will continuing publishing on SQS, but for other customers, it will publish to NATS. It is important because it means that we won't release and do a big bang in our architecture. We can do like baby steps to enable the flag just for one customer and another, and then learn in the process. If we look at the service B on AWS, we can see, looking at the red flag, that it is not running on cloud agnostic mode. But this service uh, behaves differently than service A. Service A was connected at the same time with two queue systems. Service B is connected just with one. As the flag is disabled, it is connected just with SQS. If you look at the right side of the slide, we have the same service B, but now with the flag enabled, which means that it will consume the messages just from NATs. So this slide is basically to show that what the services do depend on each case. Sometimes we will be connected with multiple technologies. Sometimes it's a matter to choosing between one or another. And I just forgot, and it's important to mention as well that we use a special feature of NATS Jetstream to forward the messages from the NATs on AWS to the NATs in the others cloud providers. This feature is called LIF. So the cloud agnostic project at Form3 is still running, and being honest, we have a long journey to complete it, but until now we have some learnings already. For sure, we know that the platform is going to be more reliable and we will increase the availability as well. As I mentioned, a problem on AWS won't affect us as it might be affected in the past. But we have some challenges as well. We have noticed some challenges. I think the first one is about tooling. We noticed that we have to improve our tooling. Our tooling is quite good already, but it's quite coupled with AWS, and we have to expand it to the other cloud providers as well. Another challenge is about networking. We are facing and working with it right now. So I hope, and I'm going to be glad to come back here in the future and share more about what we learned about how to solve that in terms of networking. And the third one, or these are just few of the examples, but this third one to mention is that the releasing part that I mentioned in one of the slides before. We cannot just enable the feature flagging now of the services, and that's it. It depends of the case. Like for some services, we might need to migrate the data from one database to another before enable a feature flag. For other services, we might need to consume all the left messages in SQS before move totally to Jetstream to NATS. So we really need to do it in baby steps. We need to do it in a progressively way. So that's it for me for today. I'm really glad to be here and thank you for attending my talk.